Hello. Thank you for returning the textbooks this week. When you return to retrieve your items, I hope you enjoyed the gifts that you received when you got to your locker. 5.3 is binomial distributions. This has many applications in the area of research and biology, and they use this often to determine the probability of outcomes in the natural environment. Today is Friday, June 12th. Goals. Define and identify the characteristics of a binomial experiment, okay, also known as Bernoulli trials. Identify the three methods for finding probability of an event having only two outcomes. The two outcomes here are success or failure. You can think back to the cookie example where I wanted a chocolate chip cookie. If I got a chocolate chip cookie, that would have been deemed a success. If I did not get a chocolate chip cookie, that would have been deemed a failure, okay? Note number 1, a binomial experiment consists of a number of trials that we call n, where there are only two outcomes, success or failure. This is very characteristic of many opportunities in life. You get into the school that you want or you don't, okay? You get a ride to school or you don't. P represents the probability of a success, where Q represents the probability of a failure. Since there are only two outcomes, the sum of P plus Q equals 1. 1 can be understood as 100%. Therefore, Q, the failure, is equal to 100% chance of your totals minus the probability of you succeeding, okay? It just means simply that if you had a 60% chance of succeeding, then the leftover amount would be 100% minus 60% to equal 40% chance of failure. That's what it's meaning. Probabilities are converting to decimals, so you would have 60% would be equal to, say, 0.6 if I had a success. Okay, and then therefore, where we deem this as P, then therefore Q would equal 1 minus the P, 1 minus P, which is 0.6. Q would be equal to 1 or 0.4. Therefore, 0.4 times 100% would be a 40% chance of failure. Okay, that's how it works. The probability of outcomes does not change from one trial to the next trial. Okay, so if I got a chocolate chip cookie, but I replaced it, then that would be characteristic of this situation. Okay? Okay, so my probabilities cannot change. The trials are independent of each other. The above characteristics are also described as Bernoulli trials. There's a family of male statisticians. There were 3 of them, all in the same Bernoulli family, and they studied these at great lengths, studying other types of math as well. Recall, a discrete random variable x, we talked about that earlier in Unit 5.1, describes an event that can have unknown outcomes. Okay, so think of the fact that you don't know what the outcome is. You either succeed or you fail, but you just don't know what is going to happen when. Okay, but each outcome is assigned a value represented by a whole number. Okay, so discrete, meaning the outcome is a whole number, okay? Random is that we don't know what the outcome will be until it happens. Variable, just meaning that it can take on different values. Let x, the discrete random variable, represent the number of heads when a coin is flipped 3 times. Now you can think of this as outcomes, right? So what are the possible outcomes? In 3 flips, you could get 0 heads in total, you could get 1 head, you could get 2 heads, or you could get 3 heads. So really, I've just described the x values as being 0, 1, 2, 3, where each of those numbers represents the total number of heads that I would possibly get when the coin is flipped 3 times. Okay, so we're going to talk about the probabilities in different ways. Create a tree diagram to show the possible outcomes of flipping a coin 3 times. Okay, so there's the start. I get a head or I get a tail. I get a head or a tail, I get a head or a tail. Okay, so that's flip 1, that's flip number 2, and flip number 3. After getting head, I could get a head, or I could get a tail. After getting a head, tail, I could get a head or a tail. After getting a tail, head, I could get a head or a tail. After getting a tail, tail, I could get a head or a tail. So the tree diagram is a visual way of looking at all the possible outcomes in a specific order, okay? So the outcomes are found by following these branches, okay? So create a tree diagram to show the possible outcomes of flipping a coin 3 times. So your outcomes could be the head, head, head. This outcome could be a head, head, tail. This outcome branch would be a head, tail, head. This outcome branch would be a head, tail, tail. This outcome branch would be a tail, head, head. This outcome branch would be a tail, head, tail. This outcome branch would be a tail, tail, head. And this outcome branch would be a tail, tail, tail. Okay? So these are my outcomes. B. Show the probability distribution of the discrete random variable x in the table of values below. So if we have said that x from here in the intro, that x represents the number of heads when the coin is flipped 3 times. X is the number of heads when coin is flipped 3 times. Okay, so it could take on a value of 0 heads after 3 coin flips. I could get 1 head after 3 coin flips. I could get 2 heads after 3 coin flips, or I could get 3 heads out of the 3 coin flips. So what is the relative frequency? Well, it's the number of successes divided by the total number of trials. Okay, so if I got 0 heads, where is that? That's 1, that's 2, so this is 2 heads, That's 2 heads, that's 2 heads, that's 1 head, that's 2 heads, that's 1 head, that's 1 head, and that's 0 heads, right? So 0 heads would be 1 time out of 1, 2, 3, 4, 5, 6, 7, 8. What is the chance or the relative frequency that I get 1 head? Okay, so this is heads. Okay, so 1 head. 1, 2, 3 out of 8. So 3 out of 8. 2 heads, what's the relative frequency? Got 1, 2, 3, 4. And then, let's see, 3, just doing quick math here to see that I haven't made a mistake. Because my numbers want to add up to 8 out of 8. And if they don't, I've made a mistake. So that's 3. There, caught it. Okay, so seeing how I fix that, right? I need to count the number here because I knew that that was too high. So I get 1, 2, 3. Okay, so what I did was as I was writing these down, I was keeping a quick total in my head. So I was adding the 1, the 3, and the 3. So right now I get 3 plus 3, which is 6 plus 1, so that's 7 out of 8. It means that I still have something left in order to get a total of 8 out of 8. As soon as I got the 4, I knew that was wrong because 4 plus 3 is 7 plus 1. That would have given me 8 out of 8, which is with the grand total that all the frequencies must add up to. Okay, so I knew that my mistake was somewhere, most likely here. Okay, and then I had to force myself to go back. So talking about reasonableness of an answer, it still is a factor in questions at this level. Okay, so here, what's the relative frequency of getting the 3 heads? So I have 1 there, but I don't have any else, any others. Okay, so in total, okay, 1/8 plus 3/8 plus 3/8 plus 1/8 is equal to, it's 4 more, 8/8. Right? So that's the total because we've looked at all the possible outcomes. Now, in B, we've shown the probability distribution in a table. Okay? C, show the probability distribution of the discrete random variable x on the graph below. So remember I said that a linear function is represented using an equation, a table of values, and a graph. It's also a linear relation can also be drawn out using pictures, although we don't do that. This is the representation of a picture. Okay? So I'm saying that what you're learning at this level right now has various representations, and it's also similar to the representations you learned about in grade 9. C, show the probability distribution of the discrete random variable x on the graph below. Okay, so we are talking about x being the number of heads in 3 coin flips or tosses. Okay, so I could have a value of 0, 1, 2, and 3, where x is equal to the number of heads in 3 coin flips. You don't usually have this part at the end, okay, but you can for sure. Okay, so now this part here is your relative frequency. Relative frequency. Because you want to show that you're going up by an equal amount, we don't ever try to reduce these values. I know that the priority has been all the way up to grade 12. You want to reduce fractions, but it's not so much in this case because we want to show that we're going up in a sequential ordered way. So this one would be, this right there would be 1/8. This one here would be 2/8. This one here would be 3/8. And this one here would be 4/8. Okay? So when x is 0, the relative frequency is 1/8. So at 0, I get 1/8 here. When x is 1, I get 3/8. When x is 2, I have 3/8. And when x is 3, I get 1/8. So just like in grade 9, this table is influencing this graph because this is like the x value and this is like the y value. Okay? All right. Now, if we took the idea that we learned earlier to expand the binomial, we could actually think about this as representing only two outcomes. Okay? The probability of getting a head, okay, so let A be the probability of getting a head, okay, and B, if the probability is getting a tail, that's basically the probability of failing, okay? So if we expand the binomial, let's see what we get. Is there any similarity between this expansion and what we've done up here, okay? So if we expand the binomial, see if you can still see, yeah. Okay, so we know that the binomial theorem is 3 choose 0, where A is the first value to the power of 3, B is the second to the power of 0. Now, I had been writing brackets around here. I mean, we can, probably would be a good way to be consistent. And then it's 3 choose 1, A to the power of 2, B to the power of 1, plus 3 choose 2, A to the power of 1, and B to the power of 2. Notice I realized I hadn't made this explicit, but what I'm going to do now will help you if you didn't understand the homework from Wednesday, is that if you have these values here, you can add them. They're always going to get the total of the exponent. So if you add 3 plus 0 would be the exponent of 3. 2 plus 1 is 3, the exponent of 3. 1 plus 2 is the exponent of 3. So if you want to know what the sums of your exponents are going to be, they always have to add up in each individual term, right? They always have to add up to the grand total of the exponent that was in the question, okay? All right, so 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. And then A is decreasing, so it's to the power of 0, and B is increasing, so it's to the power of 3. Okay, now, we were asked to expand the binomial, so we can, and I will look for my textbook. You can evaluate these using the combination formula, or you can evaluate these using your table. Doesn't really matter. Move my camera over. Okay, so 3 choose 0, 3 choose 0 is 1. A to the 3 now, I'm going to sub in, okay, so expand the binomial, then then let A equal the probability of getting ahead. So subbing in an A value of a half. Okay, so A is a half and B is a half. So A is 1/2 cubed, B is 1/2 to the 0 power, plus 3 choose 1. 3 choose 1 is 3. A is a half, B is a half, plus 3 choose 2. 3 choose 2 is 3. A is a half to the power of 1. B is a half to the power of 2, plus 3 choose 3. 3 choose 3 is 1. A is a half. And B is a half. Something interesting happens. This is 1. 1/2 cubed is 1/2 times 1/2 times 1/2. That becomes 1/8. 1/2 to any 0 power is just 1. Plus 3 times 1/2 squared is 1/2 times 1/2, which is 1/4. 1/2 to the power of 1 is 1/2. 3 times 1/2. 1/2 squared is 1/2 times 1/2, which is 1/4. Plus 1 times any power to the 0 is 1. And 1/2 cubed is 1/2 times 1/2 times 1/2, which is 1/8. Note, 1/2 cubed. You do not need a lowest common denominator. Okay, you multiply your denominators and you multiply your numerators. Okay, so that's, if you're not sure about how to fraction or use fractions and multiply there, you need to. Okay, so this is over 1. So 1 times 1/8 times 1 is 1/8. Plus, this is over 1. 3 times 1 times 1 is 3. 1 times 4 is 4 times 2 is 8. Plus 3 is over 1. 3 times 1 times 1 is 3. 1 times 2 times 4 is 8. Plus, these are 1s. 1 times 1 is 1. They're all have a denominator of 1. Times this one is 1/8. Have we seen these before? Yes, we have. These are the probability frequencies, relative. Probability frequencies. So these here are these here. I find that interesting. Okay, I'll come back and touch base with another video.